38. If the derivative of f is given by the function f prime of x equals the natural log of x plus x squared minus 6x plus 4. Let me rewrite that up here. Minus 6x plus 4. So it's a little bit easier to see. At which of the following values of x does f have a relative maximum value? And what we need to remember here, it's actually going to be a pretty quick, easy problem. We want a relative maximum, and I have a derivative. What we know is if it has a relative maximum and it's continuous, okay, and we're going to only be looking where it's continuous, what it means is that I will have relative maxima where I was sloping up and then going down. Somewhere in here will give me a max. Okay, and this means, the sloping up means I'm looking to see where f prime of x is greater than 0. And then sloping down is where, so I'll write 2, where f prime of x is less than 0. Now, if we're continuous and this happens, that's enough. If the derivative is continuous, that's where we got our critical point at the middle of this, where we got to a point where f prime of x is equal to 0. Okay? If we have this case and we have continuity, so if it's continuous, we need continuity here to be able to make this argument. Then we'll have a maximum value, we'll have a relative maximum. Don't know if it's the absolute one, but we'll have a relative maximum. So what I should do now is I need to try to figure out where this goes from positive to negative, and probably, and actually it will, since this is continuous for all positive x values, and we're only looking at positive x values here, it will be continuous. Alright, so we're going to look where f prime of x is equal to 0. So let's look at a calculator and see what we have. So I want to graph this derivative. So I want to graph the natural log of x plus x squared minus 6x plus 4. Okay, let's graph this. Alright, so we are looking for where the derivative goes from positive to negative. Let me zoom. Well, we can see this well enough. So I can see it looks like I'm starting out positive. Now that's not quite the case. If I were to turn off the axes, I know because of the way that natural log works that I'm actually going to start with some pretty negative numbers here. It doesn't show it in the graph, but I will have some negative. Let me just show you. If I were to trace, let's do 0.0001, I get a negative value. It's not shown there, but the graph starts negative, goes positive, then comes back around. So let me turn those back on, do a quick sketch, we'll talk about it, and then we'll just find our answer. If you know it already, zoom ahead a minute or so and get your answer and go on. But basically what we have here is this. So we have axes, we have this curve, and it actually starts right here. It's like this, okay? Not great, but close. And so what I know is I have a few critical points, and they all will become relative extrema in my original function. But, and this is the important part, for this critical point, I start with a negative derivative, then go to a positive derivative. This means that I start sloping down and then slope up. That's a minimum, not a maximum. This one right here, I have a positive to negative derivative, means sloping up, evening off, sloping down. That's going to be a maximum. That's what I'm going for, okay? Put a few more arrows here. Yay, answers. There. This one we can see we went from negative to positive. So we know this one is going to be another minimum. And there are a few things in here to trick us. A lot of people, don't be one of those people, are going to say that my extreme value is here, or maybe even here. Those are maximum. That's a maximum and minimum relative for the derivative, but that's not for the original function. So let's go back to the calculator and let's find that 0. So second calc, the 0, and my left bound. So I need to be to the left of my 0, so I'll make sure that I'm on the left side of that, right there. Right bound, I need to make sure that I'm on the right side of that 0. That should be good. And let me get the best guess I can put up there. And it says the 0 is when x is 0.6789, which my closest approximation here is choice A.